Hi, welcome to Zyphie's channel, and today we're gonna be reviewing the synthesis of Purine ring. Of purines. So let's do a general diagram to see how purines form. Here is the purine ring. So this end belongs to, this part connected to ribose phosphate. This this end comes from glutamine. Tetrahydrofolmyl. Hydrofolate. Formyl tetrahydrofolate. And then this, let me highlight it. The 2 C's and 1 nitrogen comes from glycine. And this C comes from CO2, aspartate, another formula, tetrahydrofolate, and you have glutamine. So that would be process 1, 2, 3, 4, 5, 6, 7. This purine ring can then form IMP, Inosinate monophosphate. And this can then transform to ATP, or GTP, and then through a special enzyme that we're going to mention later called ribonucleotide reductase. So let's see the first part. What's different between synthesis of purines and pyrimidine is that for synthesizing pyrimidine, you add the PRPP after when you form the circle. But then purine is that you add on each amino acid onto PRPP. So first, we have PRPP. As a quick revision, we have ribose, 1 phosphate. Yeah, ribose 5 phosphate. 2P form PRPP, causing ATP through PRPP synthetase. So now we have PRPP as a starting point. We first, as we mentioned on this diagram, we first use glutamine, and that'll be the first step. We're adding the amino acid onto the ring of PRPP. So here, our glutamine, that gives, you hydrolyze it and gives an amino group to the reaction. You're left with glutamate. And then you get rid of the 2 phosphate group to form 5-phosphorybosyl 1-amine. Then, as we have 5-phosphoamine, we can just add glycine. Because on this diagram, this is the second step. Glycine. Okay, remember, glycine. If we're adding amino acid onto the ring, of course, we need ATP to give us some energy. Now we have glycine amide ribonucleotide. Here, glycine amide ribonucleotide. And now, to the third part, what do? We have a 4-methyl tetrahydrofolate to add on. But this forming tetrahydrofolate gives us the 4-methyl group. So we just get tetrafolate, that 4-methyl group, to transfer onto glycine amide ribonucleotide. So we form 4-methyl glycine amide ribonucleotide. What's next? I can see on the diagram. And now we're actually adding another glutamine. You hydrolyze it to give NH3. And then, of course, you use ATP. You get 4-amino glycine, imidine, ribonucleotide. As you're nearly forming a ring, you need to enclose it. You use ATP to close the ring. And this forms an amino-imidazole. 5-amino imidazole ribonucleotide. And to the next, we have the carbon. We're adding on to a bicarbonate. So HCO3 minus, right? And something, pay attention here. In mammals, we actually don't need ATP. So pay attention on the exam, whether is they're talking about human or other species, like or mammals or other species. So here you form basically there's sort of once you add it onto the ring, it forms carboxy amino imidazole ribonucleotide. Of course, once you add on to carb, that's why you have carboxy. Then what do? We get A5. It's gonna be a long name. Amino imidazole four and succinyl carbon carboxamide ribonucleotide. And I will talk more in detail about this part, but first, you need to know that we're adding on to an aspartate by using ATP. Not sure if you still remember. Aspartate is related to Krebs cycle. And later I'll mention about that once we talk about enzymes and other details. And next, after we have five amino imidazole, 4 carboxamide ribonucleotide. Well, you can clearly see that the N-succinine disappeared. Well, how did it disappear? So basically, we got rid of fumarate. And what's next? Now comes to 4-amine tetrahydrofolate. So then we add in a tetrahydrofolate to 4-amine tetrahydrofolate to give us the forming group. And here we form 5,4-amino imidazole 5,4-amino imidazole 4 carboxamide ribonucleotide. And what's next? We enclose the circle. I strongly recommend that you have a diagram next to you so that you can see what I'm doing or how I'm explaining it, because it takes a long time to draw the diagrams. Now we get to the first part of this formation. We form Inosinate, IMP. And that's going to be the precursor to form ATP and GTP. Now, let's talk about the enzymes that we're going to use. Of course, here we know that we're going to use PRPP, synthetase. And on the first part, because we're transferring this amino group through glutamine, then the enzyme is called glutamine phosphoribosylamido aminotransferase. Because you're transferring glutamine to phosphoribosylamino, right? in this part, we're synthesizing a glycinamide ribonucleotide, which you can shorten it to GAR, girl. Because we're synthesizing it using ATP, it's glycine amide ribonucleotide synthetase. And because we're transferring a 4-amine group here, that's the 4-amine group. So we call it GAR, glycine amide ribonucleotide transformylase. And here we're adding a glutamine. And then we're forming a formylglycine amide ribonucleotide. Then it's called formylglycine amidine. Be careful, it's amidine synthetase. And next, we're actually forming an aminoimidazole ribonucleotide. So again, this is gonna be another synthetase, aminoimidazole ribonucleotide synthetase. And what's next? Another synthetase, because we're making another molecule. Carboxy basically is the product, and you add synthetase because you're synthesizing the product. Aminoimidazole nucleotide. And here again, we have another synthetase. Synthetase, transformylase, synthetase. Here, because we have succinate carbonamide and aminoimidazole succinate carboxyamide ribonucleotide. The enzyme is called succinate aminoimidazole carboxamide ribonucleotide synthetase. And then, because as we're getting rid of fumarate, it's a lyase that we're going to use. So it's called adenyl adenylosuccinate lyase. And here you get your another transformulase, because you're giving a formula group. It's gonna be amino imidazole carboxamide ribonucleotide director transformulase. You're transferring a formula group onto the amino imidazole carboxamide ribonucleotide to form amino imidazole carboxamide ribonucleotide. And lastly, because you're closing the circle, I forgot to add, you're getting rid of the water. And it's called, the enzyme, it's called inosine monophosphate cyclohydrolase, because you're closing the cycle. And here's some general diagrams, right? You first. Let's do a general review. Here. You form PRPP. First, you add glutamine to PRPP to form phosphoribosyl amine. And then second, you have a glycine. And you transfer a formula group. And then you add another glutamine. You close the first circle, the first ring, and then you add a bicarbonate to start the second ring, aspartate, get rid of the fumulate, transfer a formula, and close the second ring. And you have inosinate. And you have the ring, the purine ring. In the exam, the teacher may ask you, how would you relate the purine ring formation to Krebs cycle? So here, let me do it down here. A bit messy, but well. First, Krebs cycle. Succinate. What do you do? You form fumarate. Malate. Oxaloacetate. Right? And then you can via glutamate to form aspartate alpha keto glutarate. And here is the aspartate. And that's why here you can get rid of fumarate. So I hope you really like this video, and I think I haven't mentioned some details. And then we're gonna make another part to talk about how IMP can transform into ATP and GTP. And hope you enjoyed the video. And please comment down below to tell me if I made any mistakes. And then I hope you enjoy it. And good luck with your study. Bye.